Hello friends, in this video we are going to understand entire syllabus of Geography GS, and I hope you all will enjoy this particular lecture, what is going to be most fruitful for your preparation, right? I have given the name of topic as Introduction of Geography, right? Introduction of Geography. Here I have divided the syllabus of geography into three broad units. One is physical geography, second Indian geography, and third world geography. In physical geography, we will study the physical features, physical concepts like geomorphology, climatology, oceanography, and biogeography. In the second unit, that is Indian geography, there will be application of portion of physical geography, and the third unit also consisting of almost the component we have studied in physical geography as well as in Indian geography, right? So according to me, physical geography is the heart of geography because it is going to provide the conceptual understanding to know about the Indian system as well as the world system. Indian system as well as world system, right? Physical geography can be here divided into 4 units. One is geomorphology, second climatology, third oceanography, and fourth is the biogeography. Here we will study all the dimensions of first 3 units, but fourth unit is going to be completed in another topic, that is ecology, environment, biodiversity, and disaster management. Why? Because this fourth unit of the physical geography, that is biogeography, is the separate topic which has more weightage in preliminary examination. In preliminary test, there is the more role of this particular unit, so we must study separately. That's why we can complete the preliminary courses for environment, ecology, biodiversity, as well as the mains portion, right? So we will here focus on geomorphology, climatology, as well as oceanography, and fourth unit I will discuss separately as a topic, as a subject, right? The first unit, geomorphology. This unit is more or less much important because it is going to provide fundamental understanding for other topics like climatology as well as oceanography. Geomorphological concepts, geomorphological features going to influence the climate as well as the oceanic concepts. So this is the most fundamental in physical geography, right? Within this unit, the very first topic is internal structure of Earth. What is this? What is this? What is the internal structure of Earth? We all see Earth from outside and found what? Mountains, plateaus, plains, valleys, numerous structures, and we become able to know the surface features of the Earth. But how the Earth looks internally, we will know within this particular topic. Like in this topic of internal structure of Earth, we will study the three layers of the Earth, three shells of the Earth. One as core, then mantle, and finally crust. Crust, mantle, and core. This classification has been done on the basis of richness of minerals lying at different depths. Right? If we talk about the crust, it consists of silicon and aluminium, that's why called as Cr. In the middle portion, what is the mantle? It consisting of silicon and magnesium, that's why it is called as Sima. And the third layer is considered as Nephe, because in this layer there is the richness of nickel and ferrous. So these all parts must be studied within the internal structure of Earth. This topic will take around 3 to 4 hours to understand properly by the students. So this internal structure of Earth is going to influence formation of various landforms. As we know, inside of Earth there is presence of radioactive minerals which continuously disintegrates and produces abundance of the heat energy. And that heat energy is responsible for origin, generation, creation of the hot molten material, that is magma, and magma is responsible for movement of the outer part of the crust, outer part of the Earth, that is the crust or the plates. And due to movement of the plates under influence of convection of magma, there takes place formation of the landforms like new folded mountains, plateaus, plains, valleys, etc. Right? So necessarily this particular topic, internal structure of Earth, going to explain about every kind of the structures creating on the surface of Earth. Every type of the structures creating on the surface of Earth. So I consider this particular topic as the heart of physical geography. The internal structure of Earth is considered as heart of physical geography according to me, not by any other scholar. And UPSC may ask the same question. Justify internal structure of Earth is the heart of geomorphology. Such questions can be in the examinations. So without knowing the internal condition of the Earth, we can not be able to understand the topics like continental drift theory, plate tectonics, earthquake, volcanic eruption, rocks, and topography. That's why, according to me, not by any other scholar, internal structure of Earth is considered to be the what? Heart of geomorphology. And this topic will take around 3 to 4 hours to understand completely. Right? To understand completely. The second is the continental drift theory. The second topic is what? Continental drift theory. In short, we can say CDT. Continental drift theory, in short, we can say CDT. There is a scholar named Alfred Wegener. Scholar named Alfred Wegener. Alfred Wegener suggested very first about the movement of the land masses, and he considered the movement of continent, and he is probably first scholar who became able to justify, who became able to make it possible and gave very conceptualized theory related to the movement of land masses. He said the continents of the world, there are 7 continents in the world, and all 7 continents are moving under influence of gravitational pull of sun and moon. It is the statement of Alfred Wegener. It was realized by Alfred Wegener that under influence of gravitational pull of sun and moon, the continents are moving. How Alfred Wegener can say this? Actually, it is said because if gravitational pull of sun and moon is responsible, can play role in occurrence of the tides. If the gravitational pull of sun and moon is responsible for or is efficient for the occurrence of the tides in the oceans, in the same way there can be the movement of the continents under influence of gravitational pull of sun and moon. So Alfred Wegener visualized movement of continents on seeing the activity of the tides, movement of the ocean water under influence of gravitational pull of sun and moon. It might be that Alfred Wegener can be wrong. Alfred Wegener might be wrong in terms of his assumption that gravitational pull of sun and moon is responsible for movement of continents, but his ideology is quietly acceptable by the geographers. His ideology is quietly acceptable by the geographers, and finally Alfred Wegener gave evidences to justify his theory. What were the evidences? We will discuss in the class. We will discuss in the lecture. And Alfred Wegener also gave the mechanism to justify the movement of the continents, of the world, right? So world's continental movement has been justified by Alfred Wegener by using the mechanism as well as the evidences in the world. The third topic is related to the plate tectonics. Within the geomorphology, third topic is plate tectonics. What is this? As Alfred Wegener desired to explain the movement of continents, in the same way various scholars like Harry Hess, Paschen, Mackenzie, Wilson, etc., tried to justify this particular theory of plate tectonics. And this theory is a kind of advanced version of CDT. Plate tectonic theory is the advanced version of CDT. Why? Because in case of continental drift theory, Alfred Wegener assumed driving force of continent as gravitational pull of sun and moon, but these scholars of the plate tectonics suggested that there is the internal force. Generating inside of earth under influence of convection of magma. What we will study in the internal structure of earth, right? In the internal structure of, we will study about the generation, origin of the convection of magma. And the convection of magma is responsible for movement of the outer shell of the earth that has been considered as the plate according to the scholars of the theory plate tectonics. The Himalayan blunder done by the Alfred Wegener in terms of movement of only continents, not about the ocean bottom. This plate tectonic theory removed the shortcomings of the Alfred Wegener's and tried to explain the movement of even the ocean bottom. Continents are moving, but together the continents there are moving the ocean bottoms. And the combination of the ocean bottom as well as continents considered to be the plate. And this shortcomings was a kind of Himalayan blunder done by Alfred Wegener and removed by these scholars of the plate tectonic theory. Right? So, plate tectonic theory, in short, you can understand here, plate tectonic theory is a kind of advancement over CDT, advancement over continental drift theory, because it has more authentic driving force in form of convection of magma, convectional current of magma. Convectional current of the magma is responsible for movement of the plates, that is in form of continent as well as ocean bottom. In form of continents as well as what? Ocean bottom. Right? So, the plate tectonic theory having the capability to justify the formation of various kinds of the landforms and occurrence of geological phenomena on earth. Formation of the landforms like new folded mountains, block mountains, plateaus, plains, various volcanic structures, and occurrence of the geological phenomena like earthquake, volcanic eruptions, tsunami, landslides, etc. This theory of plate tectonics is able to explain, is able to elaborate formation of each and every kind of landforms as well as occurrence of geological phenomena with 95% accuracy. That's why plate tectonic theory is an advancement over continental drift theory. Plate tectonic theory is an advancement over continental drift theory. The next topic is earthquake and tsunami. What is earthquake? When you understand properly the concept of plate tectonics, you will easily understand the what topic of earthquake, volcanic eruption, tsunami too, and the formation of the rocks like igneous and metamorphic. At least igneous rock you will be able to understand while you are going to understand the plate tectonics. So, the plate tectonics chapter is also very necessary to understand by the students, and in examinations UPSC asks the questions based on plate tectonics too. Right? So, if we talk about the earthquakes and tsunamis, how the plate tectonics is capable to explain the earthquakes and tsunami. First of all, we must know about the definition of earthquake. Right? What is the earthquake? Sudden disturbances of earth crust. Sudden disturbances of the earth crust under internal force or external force is called earthquake. Sudden disturbances of earth crust due to internal or external forces considered as earthquake. So, in short, we can say earthquake is a phenomenon occurs under endogenetic or exogenetic processes. Generally, we experience what earthquake we experience on earth, that is associated with the internal force. And that internal force is generating inside of earth in form of, you can say, convection of magma, as well as the convection of magma is creating through what? Disintegration of radioactive minerals, right? Disintegration of radioactive minerals. As radioactive minerals are capable of producing the clean energy sources, nuclear energy, in the same way, uranium, plutonium or other minerals lying inside of earth, lying inside earth are continuously disintegrating and producing the heat energy. So, generally occurrence of earthquake takes place through internal forces, but sometimes it may be under influence of external forces too. And in external forces there is terrestrial, extraterrestrial as well as human caused forces. Human beings are also responsible for the occurrence of the earthquake to a certain extent. How? Actually, through creation of the heavy buildings, large buildings, skyscraper buildings, large dams, these structures may cause plate imbalance, ultimately going to occur the earthquake. And the next is tsunami. What is tsunami? After 2011 tsunami of the Japan, the term has become viral. What we call it? The term has become viral. Each and every individual on the earth, every human beings on earth became able to know tsunami. And literally you would also know about the tsunami, but I would like to define here. Tsunami is specific sea waves coming towards the coast, originating due to high magnitude of earthquake in deep oceans. So, if high intensity, high magnitude of earthquake occur in deep oceans, the waves originating move towards the coast are called as tsunami. And tsunami having what? Most disastrous impact. Tsunami having most disastrous impact. So, tsunami having most disastrous impact. How? Because if the sea waves gain the amplitude of 40-50 feet, under influence of such waves, there may take place submergence of the coastal cities. Coastal cities or the coastal areas, the water can introduce in much interior of the continents up to 100 kilometers. That's why it is most disastrous. It is most disastrous, and up to what extent is it? It is harmful, it is disastrous, I will discuss during the lecture. The next topic is what? Volcanic eruption. Next topic is what? Volcanic eruption. What is volcanic eruption? What is this? Upwelling of hot molten material or magma from the internal of earth. Upwelling of hot molten material or magma from the internal of earth. That is called as what? Volcanic eruption. That is called as volcanic eruption. And the main cause of the volcanic eruption is the internal force. Main cause of the volcanic eruption is the what? Internal force. Right? So, the internal force is responsible for occurrence of the volcanic eruption too. And during the volcanic eruption, there can be two types of the volcanic eruptions. One as fissure and the second as central. If eruption taking place centrally, called as central eruption, and while eruption taking place along a line linearly, then it is called as fissure eruption. Right? The next topic is rock. What is rock? Integrated form of minerals having definite shape, can be hard or soft, called as rock. So, rock is an integrated form of minerals having definite shape, lying in solid state. Lying in solid state can be hard or soft. It can be harder like the granite and softer as the what? Chalk. Chalk through which we write, or limestone. Basically, there are three types of the rocks. One is the igneous, second metamorphic, and third the sedimentary rock. There are three types of rocks. Igneous is that what is forming from fire. What is forming from what? Fire. That is called igneous. And if we talk about the metamorphic, if intense pressure and high temperature applying on the igneous and sedimentary rock, then there takes place formation of, formation of metamorphic rock, right? So, metamorphic rock is a kind of converted rock. Metamorphic rock is a kind of converted rock from igneous or the sedimentary. From igneous or sedimentary, right? From igneous or sedimentary. And what is sedimentary rock? A rock forming through process of weathering, erosion, deposition and denudation. That is called sedimentary rock. If there takes place lithification, solidification of the withered material, and there take place formation of a definite solid shape, then it is called as sedimentary rock. The next is the topography. Topography is that kind of three-dimensional solid structures which forming under influence of external forces. So, whatever the structures have created, in the process of formation of rocks, volcanic eruption or earthquake, plate tectonics, continental drift theory, or internal conditions of earth, those are balanced by external forces. And when the external forces going to balance the outer surface of the earth, the structures forming in between the process, those are called as topography. So, whatever the structures have created under effect of internal forces in the process of volcanic eruption, earthquake, in plate movement, process of tectonism, continental drifts, etc., that is balanced under the process of formation of topographies. So, there are actually 5 types of topographies. Basically. One is the river topography. One is the what? River topography. Second, karst topography, K-A-R-S-T, karst topography. Third, arid topography. Fourth as arid topography. Fourth as coastal topography, and fifth as glacier topography. So, there are 5 types of topographies what we can understand. So, these all kinds of topographies we will discuss during the lectures. The next unit is climatology, and have patience to understand this topic also. Within the climatology, we will study actually the first definition of atmosphere, its composition and classification. Definition of atmosphere, its composition and classification. Second is definition of troposphere and associated aspects. Then solar radiation, solar insolation, distribution of temperature horizontally as well as vertically. So I'm not going to read these topics. I'm just going to elaborate up to certain up to certain extent. That's why you must be at least familiar of these topics. You must be familiar of at least these topics, right? So first of all, definition of atmosphere. What is definition of atmosphere according to all the learners or the listeners? Definition of atmosphere is mixture of gases solid particles, mixture of gases, solid particles and water extending up to 1000 kilometer from the surface of Earth. From the surface of Earth is called as atmosphere. Is called as what? Atmosphere. Right, is called as atmosphere. So we can define atmosphere as mixture of solid, liquid and gases extending up to 1000 kilometer from surface of Earth, enveloping the whole Earth is called as atmosphere. Called as atmosphere. The atmosphere can be classified into 5 categories. Atmosphere can be classified into 5 categories. Right, can be classified into 5 categories. One as troposphere. It is the lowest layer of the atmosphere, extending up to 15-18 kilometer along the equator and up to 8 kilometer along the poles. And within this layer of the atmosphere temperature decreases with increasing altitude, that is also called as normal lapse rate. The second layer of the atmosphere is as stratosphere. Third, mesosphere. Fourth, ionosphere. And fifth as the what? Exosphere. So this is the actually classification of the atmosphere. In troposphere, temperature decreases with height. In the stratosphere, temperature increases with height. In mesosphere, again temperature decreases with height. In ionosphere and exosphere, temperature increases with increasing altitude. The next topic, definition of troposphere and associated aspects. Definition of troposphere and associated aspects. What is definition of troposphere? Troposphere is the lowest layer of the atmosphere, extending averagely up to 12 kilometer, extending averagely up to 12 kilometer altitude, around 16 kilometer along the equator and 8 kilometer above the poles. altitude of the troposphere decreases continuously from equator towards pole, right? And in the troposphere, temperature decreases with increasing height. That is also called as normal lapse rate. Temperature decreases with 6.5 degrees Celsius per kilometer. Temperature decreases by 6.5 degrees Celsius per kilometer, or 1 degree Celsius per 165 meter. The next is the solar radiation and solar insolation. What is solar radiation? What is the solar radiation? Electromagnetic radiations released from the surface of sun, that is in form of solar radiation. Solar radiation is that part of energy that is being emitted from the surface of sun and reaching to the different part of the solar system, that is called solar radiation. And the solar insolation is the part of the solar radiation reaching to earth with the different angles on surface, right? From equator towards pole, angle of the radiation, angle of the sun rays is going to decrease. Angle of the radiation going to decrease. Angle of the sun rays going to what? Angle of the sun rays going to reduce. And in this way, the rate of heating also going to reduce from equator towards pole. This is called actually the solar insolation. Solar insolation is directly associated to the heating of the earth's surface, heating of the atmosphere, because the energy interacting with the atmosphere or the surface of earth or the surface of ocean hydrosphere, that is associated to the solar insolation. The next is distribution of temperature. If we talk about distribution of temperature, it is associated to the atmosphere. In atmosphere, temperature is studied in two ways. One is the vertical distribution and the second is the horizontal distribution. Within the climatology, listen very carefully, within the climatology, vertical distribution refers to vertical distribution of temperature is studied in the troposphere. Vertical distribution of temperature is studied in troposphere, right? In troposphere. Because of the decreasing air density, with height or increasing intermolecular space results into what? Reduction in temperature. Results into reduction in temperature with height. So in this case, if we draw a graph with height related to the height and temperature is going to reduce. Temperature is going to reduce with height. Why? Because of the increasing the intermolecular distance, short and long wave radiation is trapped lessly with height. The next is the horizontal distribution of temperature. From equator towards pole, temperature decreases from equator towards pole. This process of studying the temperature is called as horizontal distribution of temperature. That is called as horizontal distribution of temperature. Next topic is normal lapse rate. Next topic is related to the normal lapse rate. What is this? Reducing temperature in troposphere with increasing height, that is called normal lapse rate. It is 6.5 degrees Celsius per kilometer. What is temperature inversion? If temperature increases with height, in troposphere, because of various factors, then called as temperature inversion. What are the factors? What are the factors? Altitude, latitude, length of day and night, length of day and night, rotation of earth, revolution of earth, seasonal changes, etc. These are responsible for origin of temperature inversion, right? Temperature inversion, responsible for origin of temperature inversion. Next topic is heat budget. What is heat budget? Sum total of receipt and release of the heat energy. Sum total of receipt and release of heat energy of the atmosphere is called as atmospheric heat budget. The ultimate source of energy for maintaining the heat budget associated to the solar radiation or solar insolation. Sun's energy is ultimately responsible for maintenance of the heat budget. Heat budget maintenance is done by that solar energy. The next is the what? Heat island. What are the heat islands? Heat island is associated to the large urban habitats of the world. Heat island is associated with the large urban habitats of the world created due to the industrialization, urbanization, deforestation, infrastructural development, etc. These are the factors actually responsible for accumulate more the heat energy from sun as well as terrestrial radiation. From solar radiation as well as terrestrial radiation, heat energy is being accumulated more in the large urban habitats, basically because of concrete jungle, metallic infrastructure and introduction of greenhouse gases to the atmosphere, concentration of greenhouse gases to the atmosphere, right? Concentration of greenhouse gases to the atmosphere. So this is about heat island. Delhi can be considered as heat island because there is the concentration of concrete jungle, metallic infrastructure and concentration of greenhouse gases like CO2, methane, water vapor, CFC, HCFC, etc. The next topic is definition of pressure and associated aspects. What is the definition of atmosphere? Definition of pressure? Force exerted on per unit area is called pressure. Force exerted on per unit area is called pressure. The next is the what? Wind and wind system. Wind and wind system. What is wind? Movement of air from high pressure to low pressure is called wind. Movement of air from high pressure to low pressure is called wind. And in case of wind system, there are 4 types of winds. One is planetary wind, second seasonal wind, third as the local winds, and fourth as diurnal winds. There are 4 types of the wind we will study during the lecture. Next topic here is given: planetary winds, seasonal winds, diurnal winds and the local winds. The next is the what? Formation of clouds, classification, how the clouds form. The process of formation of cloud is associated to the heating, evaporation, condensation, condensation and saturation. These are the processes related to the formation of the clouds. And clouds can be classified into 3 categories on the basis of altitude. On the basis of altitude as low, alto and high clouds. There are again various clouds like cumulus clouds, stratus cumulus clouds, and within this topic we will also study burst of clouds. What is very important. The next is air mass. With the climatology, next topic is air mass. What is air mass? Accumulated form of air due to homogeneous relief, temperature, pressure, humidity, normal lapse rate, etc. going to create air mass. Going to create what? Air mass. The next topic In climatology is cyclone. What is cyclone? Rotating wind, right? Rotating wind under influence of differential pressure. Rotating wind under influence of differential pressure and rotation of earth. That is called cyclone. In short, cyclones are of two types. One is tropical cyclones and second is temperate cyclones. Tropical cyclones are those originating in tropical regions in ocean, on the surface of ocean, due to differential temperature. But if we talk about the temperate cyclones, these are an outcome of convergence of two contrast nature of air masses. Right? So this is about the temperate cyclones. The 12th topic is here as humidity, associated aspect, types of humidity and capacity of humidity. The first is humidity. What is humidity? Presence of water vapor in air is called humidity, right? Presence of water vapor in air is called humidity. On the basis of different mechanism of measurement of water vapor in air, humidity is categorized into three types. One as the absolute humidity, second as what? Specific humidity, and third as relative humidity. These are the three types of humidity. One additional point you will study, that is the capacity of humidity. Retaining power of water vapor by air is called capacity of humidity. 13th topic is related to rainfall and their types. What is rainfall? Falling of water droplets under influence of earth gravity is called rainfall. These all topics, remember every point of time that these all topics will take much time. Just I am here introducing the syllabus only. Remember this point and never forget. So what is the definition of rainfall? Rainfall is falling of water droplets under influence of earth gravity from certain height of the troposphere. There are three types of rainfall. If we talk about the types of the rainfall, there are three types of rainfall. One is the orographic rainfall, second is cyclonic rainfall, and third is the what? Convectional rainfall. Convectional, cyclonic. One orographic, second cyclonic, third convectional rainfall. And we will have to study these points in detail. Only the orographic rainfall will take at least 30 minutes, half an hour. Then precipitation and their types. What is precipitation? Falling of water molecules in form of solid, liquid or gases under influence of earth gravity from certain height of troposphere to the surface is called as the precipitation. There are various types of precipitation, and one of them is the rainfall. Rainfall can be considered as subset of the precipitation, right? So rainfall, then hails, sleets, not sheet, sleets, snowfall, fog, mist, dew and smog, etc. These are the types of precipitation. This particular topic, precipitation, will take at least around 2 hours to understand its conceptualization, its concepts, right? And the remaining topics are like oceanography, Indian geography and world geography. That we will discuss in the next class. All the best to all of you. Have a nice time. Goodbye.